Okay, so I'm going to review real quickly over what we have done for the past couple of days. Last week, we were able to get through several different things with proportional versus non-proportional relationships. Remember that if a relationship is proportional, then when you take the y value and divide it by the x value, you will get the same number every single time. Every one of your y's divided by their corresponding x's will simplify to the same thing. That makes it proportional. If it was not proportional, then when we did a y value divided by the x value, they were not the same every single time. So like 10 over 1 and 17 over 2 were not equal values, so that makes it non-proportional. So we talked about that information. We then went in to talk about how if it is proportional as a graph, that means it has to be a straight line and it has to pass through that 0, 0 point, that origin. Origin and straight. Remember, we had to check off on both of them in order for them to be proportional values. And then we can identify our unit rate by looking at where x was equal to 1. When x was equal to 1 and we followed it up to the line and then looked at what y would equal, that was our unit rate. Okay, so we looked at several examples of proportional graphs. We even saw an example of a non-proportional graph. It was still a straight line, but it did not cross through the origin. Since it didn't cross through the origin, it made it non-proportional, which made sense when we took our y's and divided them by x's. We did not get constant unit rates. Okay, so we saw a bunch of that last week. So now what we're going to be looking at is what proportional relationships look like as equations. Okay, so when we were doing our IXLs, we saw a couple of problems in which we said, hey, how do we know if this equation is a proportional relationship or not? And I told you guys, well, if you had to add or subtract something, it made it not proportional. Not having addition or subtraction, it made it a proportional relationship. So let's take a look at to y. Yes, we started notes. Okay, so here in our equation, we are looking for our k value, which is our constant of proportionality. We call that k. And that's when we take our y value, like we said before, unit rates or constant of proportionality is always y divided by x. It is always the y divided by the x. Okay, so when we write it as an equation, we write it as y equals k times x, where y and x are just variables, and k is that value, y divided by x. Okay? And now it's important for you also to understand that when we are talking about our k, our constant of proportionality, k is always going to be equal to some number of whatever y's you've got per 1x. K is always going to be written as the number that you find. When you take your y and divide it by x, it's going to give you a number, and you write it as words of how whatever your y is, like maybe it's miles per 1x, maybe it's per 1 hour. So these are going to be words that you're going to fill in. You have to identify what is the label for your y's and what is the label for your x. Okay, so let's take a look at an example here. We have hours and we have miles. We have 2 hours is 120 miles. 5 hours is 300 miles. 9 hours is going to be 540 miles. Leave her drink alone, Phoenix. Okay, so we want to find the constant of proportionality. So which one of these values, hours or miles, is going to be our y? And if you need help, look at your tables. How do we typically set up our tables? Which one of these is going to be our y value? San Antonio? Miles. Very good. So right next to miles, I'm going to write a y. That means right next to hours, I'm going to write an x. So my x values are hours. Okay, so when I'm trying to figure out what k is going to be equal to, again, we set it up as y divided by x. We're going to do y divided by x. So that means here we're going to do 120 and we're going to divide it by 2. We're also going to do 300 and we're going to divide it by 5. And we'll do 540 and we'll divide it by 9. Okay, we're taking each individual y and we're dividing them by their corresponding x, the x that's paired up with it. Okay, and then we want to see, remember, if it's proportional, they should all equal the same value. So if we do 120 and we divide it by 2, what are we going to get? What's 120 divided by 2? 60. Good, Santonio. Okay, if we do 300 and we divide it by 5, we're also going to get 60. If we do 540 and we divide it by 9, we are also going to get 60. So all of these are equal to each other. That means that our value for k is going to be equal to 60. Now, I can't just leave it as a number. Remember, I said k is a number of whatever our y is per whatever our x is. Now, remember, the y and the x are no longer numbers. Those are labels. In this problem, what was the label for y? What did y represent? Ivana? Miles. Y represented miles. So that means that this is 60 miles per one of the x. What did x represent in this problem? Hours. X represented hours. So we would put 60 miles per hour, just one single hour. That is our constant of proportionality. Now, if I wanted to write the equation, because you're going to have to know how to set it up as an equation, we only have one value that we're plugging into our equation. So our equation is just y equals 60x. And then you're done. Y is equal to 60x. That is the equation of this problem. So again, our constant of proportionality, you took the y and divided by the x to get your number for your constant of proportionality. You related it back to the y's per x, so in this case miles per hour, and then you set it up as an equation. Y equals whatever your k factor is times x. Now some problems are real simple. We take a look here. Neil is practicing for his typing test. The equation y equals 45x represents the total number of words y that he can type in x minutes. What is the constant of proportionality? They told you the constant of proportionality right away. What was it? Jordan? 45. 45 is my constant of proportionality. 45 is my constant of proportionality. Can I just say, oh, it's 45?
Miss French-Zheng?
Yes, ma'am. Can I just leave this as 45? No, there's missing. Something's missing. Let's take a look here. Remember, we put k was equal to 60 miles per hour. So am I going to just write miles per hour here too? No, because was this problem about miles and hours? No, what is this problem about? Okay, the number of minutes, there's one thing. What else? Words, right? Words that could be typed, right? So here, it says it here, Y is the number of words. Y is the number of words. X is the number of minutes. So when I'm putting my information down, I need to put it as Y per X. Don't forget, it is Y per X. It is always Y per X. So our Y was words. It's 45 words per X. Our X was minutes. So it's per minute. That's our constant of proportionality. 45 words per minute. I don't have to write my equation because they gave me the equation already. I'm using that equation to identify my constant of proportionality. I want you guys to try problem 3 on your own. Okay. The distance y traveled in miles by the Tran family in X hours is represented by the equation y is equal to 55x. So what is my constant of proportionality? Who can tell me? No, don't just tell me a number. Tell me like 60 miles per hour or 45 words per minute. What is it going to be? Jada? 55 miles per hour. Good. Guys, in the problem, it will tell you what your y stands for, right? Y is the miles. Y is your miles. It'll tell you what your X stands for. X is the hours. X stands for the hours. And then they gave you the equation. The 55 here represents that constant of proportionality. It represents that rate of change that we've got going on here. So K is equal to 55, and again, miles per hour, right? It's whatever our y is per whatever our x is. It's y per x, whatever your y value was per whatever your x was. Okay, go ahead and flip it to the next page. Try problem 4 on your own. Okay, who can tell me what is the constant proportionality if we've got a number of calories y that X cookies have is represented by the equation y is equal to 125x. Corey? The whole thing. Very good. So we have calories is going to represent our y. Y represents the number of calories. X represents the number of cookies. Okay, and then we have our constant of proportionality, 125 for the number. So K is equal to 125 calories per cookie. Okay, 125 calories per cookie. All right, so that's when they're giving you an equation. We saw what to do if they gave us a table, right? We know how to do a lot of those tables. You always take the y divided by the x. Here's when they give us some graphs. If they're giving us graphs and we want to know what is the constant of proportionality and then write our equation for that constant of proportionality. So if we're taking a look here, they give us a line, and what we have to do is we have to identify a point on the line. Any point. It doesn't matter which point you pick on the line as long as it goes perfectly through the grid. So we've got several different points here. I'm going to go ahead and choose this point all the way up at the top that they gave to me. So taking a look at this point, I want to know, first of all, what is the value for x and y? Now, who remembers when we're looking at a grid, which axis is going to be x? Is it going to be the horizontal axis that goes left and right? Or is it going to be the vertical axis that goes up and down? Which one of those axes represents the x-axis? CJ? The horizontal. Good. Horizontal represents our x-axis. So I'm going to put an x there. That means that my vertical is going to represent my y-axis. So I'm going to put y up top here. Okay, I want to do that because when I'm looking at this point tells me exactly what the value of my y is and what the value of my x is if I follow it down and to the side. So if I start at my point and I follow it all the way down, what is the value of my x? 10. My x is a value of 10. What's the value of y going to be? 50. Good. If I follow it all the way to the side till I get to the y-axis, it's at 50. So I know what my value of y and x are going to be. So then we can substitute it back into the problem. We can say, hey, k is equal to, what goes on top, x or y? Y. Y goes on top, right? We're going to put y on the top. So we're going to put 50 on the top, and we're going to put 10 on the bottom. And then we simplify it. What is 50 divided by 10? 5. So we're going to get 5. Now remember, I can't just put 5. It can't just be a number. It has to be y per x. Well, they didn't give me a word problem, but they did give me labels, didn't they? So what is it? It's 5 what? Santonio? It's per minute, yeah. But what is it? What's the y stand for? Water used, right? But I'm not going to say 5 water used. I have to have a unit of measure. What's the unit of measure that they used? Gallons, right? They used gallons. So it's 5 gallons per minute. Good. 5 gallons per minute. Okay, 5 gallons per minute. That's my value for K. And now I need to write the equation. I need to set it up as an equation. Who can tell me what is the equation going to be? Christian? Very good. Y equals 5x. So there's my equation, and there's my constant of proportionality. Again, you just have to identify a point on the graph, identify what the value of your y was, what's the value of your x, and then set it up, y over x. Don't forget to relate it back to the labels of it. So remember, we don't say 5 water used, we'd say 5 gallons, right? That's the unit. We don't say per time, we say what the time was, minutes. Okay, you relate it back to its specific details. I want you guys to do problem 6 and the other problem. Do the remainder of the page, please. Don't forget to identify the equation as well. Sure, if you don't mind spending, 6 or 7 days in silent lunch. Yeah? You want? No? You sure? Okay. Okay, if we're taking a look at problem 6, we're identifying the constant of proportionality and then writing the equation. So for here, our y-axis is talking about money, right? It's a cost, it's money. And then our x-axis is talking about magnets. So I want to make sure I understand what we're relating it back to. I'm going to pick any point on here. So there's many points we could have picked. We could have picked right here where the x is a 2 and the y was a 3. You could have picked right here where the x was a 4 and the y was a 6. You could have picked right here where the x was a 6 and the y was a 9. So it doesn't matter which point you choose, but you have to choose one of them. I'm going to go ahead and choose the middle point, where, again, my x in this situation was a 4, and my y in this situation was a 6. So when I'm setting it up, k is going to be equal to 6 over 4. And then, like always, we want to divide. We're just going to divide 6 divided by 4. 6 divided by 4 is going to come out to 1.5. But we're talking about dollars, right? So where do I put my dollar sign, in the front or in the back? In the front, right? I have to put my dollar sign in the front. So I'm going to put a dollar sign. So it's 1.5 dollars. Do I really write 1.5 though for dollars? You need a 0. Good. We need a 0. So it's $1.50 per what? Per magnet.
I could just still buy a different.
That's fine. Yeah, that's good. If you did 3 and 2, 3 divided by 2 is $1.50. You could have done 9 divided by 6, $1.50. Quiet. Okay, when we write this as an equation, for the equation, what is it going to look like? Jada? What's your K factor? Or 1.50. 1.50, and then x. Yeah. Okay. All right, so there's our constant of proportionality. There's our equation. Let's take a look at the next problem. For here, this time, x is representing the minutes. Stop talking. X is representing the minutes. Y is representing the feet, the distance in feet. Again, we just pick any value on here that is a perfect cross on the grid. There's only one point on here that is a perfect crossing on the grid, and that's right here. That's the only point that's going to work that perfectly intersects. Like here, we had 3 points that were perfect intersections on the grid. This one only shows us one perfect intersection on the grid. So we're going to use that as our point. And here, x is going to be equal to 1, and y is going to be equal to 6. So when we're setting this up, we're going to have k is equal to 6 over 1, which is just equal to 6. And don't forget, it has to be 6 blank per blank. So it's 6 what per what? Santonio, that's silent lunch. Okay. It's Ivana. Feet per minute. Thank you. So we have 6 feet per minute. Good. So we have 6 feet per minute. And then what is the equation going to be? What's the equation going to be? Corey?
Y equals 6x.
Good. Y equals 6x. That's it. Okay. So load it into Google Classroom. You're going to have your Wayground activity.